Do you have your Arduino board with you?
Yeah.
Yep. Let's bring it. I don't know how it will go today, but we have to finish all the in-class exercise today, during today's lecture. And it's due Wednesday, and originally I put on Canvas, said it's on paper, but now I changed my mind because a lot of them are, I'm asking to verify it with Arduino. So if you already typed in Arduino, why not just copy and paste into the paper, right? So what I'm thinking is, I just look at the instruction I'm putting on Canvas. So I'm asking you to type in Arduino and show the results from a serial monitor and make a snapshot of both, and then append it to your assignment. I believe, for example, the first one. If you look at the first one, it's not a complete Arduino code. It's just a piece of the for loop. So there's no way that I can verify that one. So I think starting from number 6. I put it in Canvas, so 6, 7 or something. You see look at the numbers, the ones that ask you to verify, then you just verify it. For the rest, you don't have to verify. You can type or handwrite on the paper, doesn't matter. Just scan it, take a picture of it. I don't really care. Okay, so we just have to finish everything today. If I cannot run every single problem, I'll pick up the important ones, or the ones that I think you will probably fail. So we'll go through these ones, and the rest of them you'll just work on it by yourself. Not too many, maybe just one or half that I have to figure it out by yourself. So for the rest of the week, including Thursday's office hours, and I picked up, is that 10 to 12? 10 to 12. Okay, 10 a.m. to noon. Based on the survey, are you guys available? I think just one student only has 1 hour available during that 2-hour time frame. But for the most of you guys are available. Okay? Is that correct?
Yeah.
Okay. So 10 to 12, make sure you'll show up in the lab. 6:10, I'm gonna set everything up before that. So we'll start soldering. But actually Wednesday, I think, I plan for Wednesday for just soldering as well. Or don't have lectures, just soldering.
I work until 5 on Thursdays, because I don't have classes that day. Can I just do it? Is it mandatory?
It's not mandatory. You can come later if you are confident on that. Yeah. Are comfortable doing that by yourself? Okay, cool. Yeah. So if I finish early today for all the in-class exercise, then I'm gonna show some of the details of the board and tell you how to assemble it. Okay. So look at number 6, problem number 6. So this is the problem I would like you to type it now, okay? So you don't have to put a number for M and N, but now start typing. So it's creating a 2D array. The 2D array? Yeah, it's a 2D array for screens. Then we'll see if we can get a correct result over here. Okay. So define a variable here, a constant here, and we'll come back to this point and see what the number should be putting here, okay? Just leave it blank. And then define space, character, buffer. Remember what the buffer was used for? For printing, right? For printing. It's storing that specific format that's specified by that specifier here. It's temporarily being stored in the buffer. And it doesn't have to be 20, could be 20, could be anything else. It's just a random number. just creating a space. Setup, curly bracket, it's a character array, command array, m, n here equals so pay attention to the longest word in here. How many letters are in there? Okay. Print something in the buffer first. Person C is the specifier for a character. It's gonna print out the character. It's picking up row 1, column 1. That specific character to be printed out. Of course, you need a serial begin to set up the serial port. Then just print the line for once from the buffer, okay? Because the buffer stores that certain format from that sprintf function. So for the loop, we are not running anything as a loop, okay? Just keep it blank. Nothing should be in there. So what should be put in m and n? That's the question for you guys. This should be justified to the left. See here, m is the number of rows, and n is the number of columns. So we can do this to make it a little bit more clear. Okay, how many rows? 3. How many columns as a maximum? 5. Remember, for strings you have one extra one after the last character. It's called null, right? So we need to give how many spaces over there? 6. So n should be what? 6. Okay, that's the column number. And m should be 3. It's gonna work. Okay, so in that case, row 1, column 1 is gonna be what? So that's row 0. That's row 1. And that's column 0, that's column 1. So row 1, column 1 will be O. Okay, let's try it. Connect it to the Arduino board for the port. And find out the port from tools, port number, which is COM4, and the board is correct. Just double check that, and then directly upload the code to the board. Something's wrong. What is that? Define. Is a typo somewhere? You'll find my typo. there shouldn't be a semicolon after this. Sorry about that. Good lesson to learn. All right, upload. Okay, go to Tools, Serial Monitor, and prints out the O here. Okay. I'm wondering if I don't give a 6 spaces, if I do a 5, see if that works. Probably will, but I'm wondering if I can do a, if I can still print out Y here, which is gonna be row 2 and column 4. See if that works. Serial monitor. You're still able to do that. But the thing is, you won't be able to have a null after it. But a lot of times we do need a null after Y, so as a, for the string, because a lot of times we are detecting that null to know that it's the end of the string. So we do need that, even though it's able to pass the compiler, but it's not a good practice, right? Any question on this one? Did you all get that all printed out? All right, so you can work on that after class if you couldn't get it out. And now we have to keep moving. Okay, move forward. And this is problem 8. Copy and comment it out. And then start problem 9 here. It's very similar, so I just copy and paste. So problem 9, write a C code snippet that takes an 8-bit integer representing ASCII character between 0 and 9 and returns a decimal value. So it's taking in the character and returns the decimal value, corresponding decimal value on the ASCII table. So any idea about that? It should be just a very easy trick with the specifier, right? But the thing is, for example, I have a character number 3, right? I have a quotation around it because it's a character, it's not a number, right? I define it as a character. So let me show you that really quick. So like character, I'm calling it a number. Actually, it's not a number. 3. So the goal is to print out the 3 as a number, not a character. How do we do that? If I directly just print out this, for example, right? Print f, assuming I have a buffer already, okay? I'm doing C U actually of that number. Will that work? No, because 3 in the ASCII code on the table is not actually 3, right? It's something else. But this could be something not exactly 3. Could be a random character like A 9. Doesn't matter. So look at 3 here. See if you can find any clue from this. 3 is so 3 is actually 51. So if you print it out that character as a unsigned decimal number, it's gonna be 51. But I need a 3. Okay? So this is a very popular technique, and you'll use this a lot in the semester. So what you can do is you directly minus the character 0. So it actually allows you to use a character to minus a character. Okay. So eventually you gotta get the offset. You can see 51 minus 48 is going to be 3, right? And then you print out that result as a person U. Okay, you know what I mean? It happens a lot also for letters. Okay, we'll have another example for later. It's asking you to convert lowercase letter to an uppercase letter, from an uppercase letter to a lowercase. It's a very similar concept. You're just directly using that offset, the difference. Not offset, sorry. So the difference between that character or letter from 0. If you are doing a letter, you'll actually find out the difference from A. We'll see that example in a bit. But now, for this example, it allows you to deduct a character from a character. So now let's start typing it and see if that makes sense to you guys. So what we can do here is we have a character 3. It's an input. It can be changed. Okay, and then we have to give a space for the result. Let's call it value. Right, and definitely we need a buffer. Still give a 20 in there because it's more than enough than we need. And now we do setup. So I don't really need that. So setup value equals, so here's where we do the subtraction. So value is a result, and we need this character minus what? 0. And then we just print out. We directly use this one. Okay, we just print out that value, the result, as an unsigned decimal. And then we copy and paste those is serial settings. And we need a semicolon here. All right. And we can reuse this one. I'm just so lazy. Reuse it, and all the rest are useless. Let's try it. I'm going to connect my Arduino board to the computer and upload it. Monitor. Yeah, it's number 3. You can change it to a different one. For example, I change it to 8 and rerun it. Print out 8 just for once, okay? That's a tactic you need to know. And now let's keep going. I think another one I want to run with you guys is number 10. So number 10, you need to learn how to do that as well. But I will just type the most critical line instead of the whole thing. Problem 10, all right? So it's asking you to convert the uppercase letter into an equivalent lowercase letter and print it out in Arduino serial monitor. How to do that? Since now we know that, we can do subtraction with characters. Okay. So if you just directly, so that it's given. So I'm gonna type that for you guys here for now. So the uppercase letter to lowercase, so which means the uppercase, let's call it upper, and this one is given, okay? For example, F. It's F. It's given. So you need to design a little function. It's actually just a one line, not even a function in setup. Just only print it out once, and that line should convert this one to its corresponding lowercase letter. Okay. How do we do that? If you look at the ASCII code, we can give a space to lower result. Just call it lower. It's a result, and it follows the same routine. So you need to do the setup, then loop, then buffer, whatever. But eventually, I'm just not typing everything for you guys. So eventually you need a one line. So the critical line is going to be lower. So this one need to be upper. So the uppercase, if you look at the ASCII code, look at the upper, whatever, this upper letter, whichever that is, okay? I use that upper letter's character minus A, uppercase A, so I'm getting a difference. And that difference should be the same difference over here for the lowercase. Does that make sense? So if I subtract uppercase A, use a character subtraction, and if I want to convert it back to its corresponding lowercase, what should I do? Subtract the uppercase A and do what? So that uppercase character minus uppercase A, I'm getting the difference between F and A. For example, it's F. Okay, F and A, I'm getting that difference.
Minus 0?
There's no zero, it's letters. So letters, all the letters are using these numbers, right? Now there's nothing about zero. So this minus this, I'm getting the difference between F and A, okay? Now, it's just a difference, or it's a distance between F and A. And now I want to convert it back to its lowercase. Can I just directly add that offset, which is lowercase a? That makes sense? Because the difference between uppercase A to this uppercase whatever letter is, it's going to be the same distance between this lowercase a to whatever that same letter's lowercase is. So if you use this uppercase, which is given, minus that uppercase a, and I directly immediately add a lowercase a character in there, then I'm directly adding that difference to that location. So I'm getting that corresponding lowercase. So eventually this is going to be minus uppercase a and plus lowercase a. Does that make sense to you guys? Okay. So another technique that you need to know. Why we care about ASCII code so much? Because serial communication is all about ASCII. These are all, how many bits in these characters? How many bits? Very simple question. How many bits are in there? 8. It's a byte. So all these are bytes. So the serial UART are just sending bytes. Okay, so ASCII code are bytes. Also the keyboard. The keyboard you are typing right now, they are just ASCII code. So press the key, sending ASCII code to the computer. Okay, it's a byte. Okay, can you complete the code? Just use the same routine we already showed you guys. Okay, it's for you to complete. Okay, it's number 10. So the result is given to you, right? It's just that you just need to put buffers, sprint f, the print, the loop and setup. Okay, should be reasonable. And now look at number 11. Any questions by far? There? Any questions over there? No? Okay, so this is just a question. But if I ask you to type it, then you have to type it and show the result. But now, it's a very simple question here. It's asking you that if I in the setup function affect the I in the foo function, it's a function doing nothing, it's called foo. And if you look at these set up, have a declared I, and 0 begin, for loop. If you look at the for loop here, it's a little bit different because there's no curly bracket. If it's a one-liner, so it's a for loop, no curly bracket, followed by a function, which is fine because there's no multiple lines. It's just one line. You don't need the curly bracket. So directly just follow the for loop statement, the conditions, which is fine. And so this is going to be still a for loop. This, and semicolon ends it. So this for loop is going to keep calling this function over here outside of the loop function, which is over here. Okay, just keep calling that. So every time it calls it once. Okay, that's how that works. Do we have a variable for loops? It's just an argument. Okay, so whatever this I being taken into this function will be used as argument for loops. All right, and that number will be used for the for loop over here and printing out a very simple string. So what is this actually doing? So what's the result will look like? Can you imagine that?
The first time it goes through the for loop, it'll print it through 0 times, and then it'll loop through again, and it'll print it once, loop through again twice.
Yeah, will be like this, right? Okay. So the first one just 1 or 0, and then 1, 2, 3, 4, 5, like this. Okay. Eventually it's like triangle shape, just printing out the same thing, the strings, but multiple ones. Wait, it's not a. It's actually not a triangle shape because it's using a print line, so it's actually changing a new line every time it prints it. Okay, so it's actually first time just 0, second time put a 1, second time 2, 3, 4, 5, like that. But eventually you'll get a lot of fools in the column, just one column. But that's not important though. So what is important is asking you, is the I over here being affected by the I over here? So it's the same name. And whenever this is being looped, and you are having I being changed. So the question is this I affecting this I or not? No, because this is a local variable. It's called a local variable because it's within that function. And that's called local. Okay, it's a local variable. It's just a definition. Keep that in mind. If you have that variable being put in that function, inside that setup function or different function, it's a local variable. It's not visible to the other functions. Okay, so whatever is changing here is not changing the variable over here.
Yeah, also, even if it was a global variable, aren't you still setting I to 0 in the loop as well?
I'm not getting that. Say it again.
So like even if like I was like a global variable, you're still setting I to 0 at the beginning of the second for loop, so it still won't have any effect on it, right?
But let me see. But every time it calls it, it comes through here,
Yeah, and then
right? So this is not 0 anymore.
yeah, but then
This keeps going.
yeah, so this runs once, right? And
Yeah.
after it runs I is equal to 5, but then in your for loop you're setting I is equal to 0, so it's
Yeah, it's the I, but this I is not going back to 0.
yeah, I know what I'm saying, but like
Yeah. This is not being affected,
yeah.
right? But the key point is this is not changing. So it stays. It keeps going up.
Okay.
That's the key point.
Okay.
Okay. Make sense? Number 12. In the following code snippet, what are the results of sum and average? Okay. So this is pretty much at the end. We have 12, 13, 14. That's it. Okay, so look at this one. Look at this one. It's a very simple code to calculate the average from a sum. And we have a function here to do the summation. Let's go it from top to bottom. Set up, declare array, and I declare this array. Different from C++, we're setting up the baud rate. And this is doing everything within the loop. It's not calling a function this time, even though it's still a one-liner. So what's gonna happen over here? So n is 8, right? N is 8. And for this line, it will assign all the i's to array and stop and finish it. And make the array, whatever the numbers in the array, to be ready. So in that case, what are being stored in the array? Because we are giving I to all these locations in the array, right? So if it's a location 0, we put a 0 in there. If it's location 1, we put a 1 in there. Okay, until what? Until 7, because this n is 8. So whenever it reaches 7, it will still put a 7 in it, and I equals 8, and then comes back to the for loop, and I equals 8 won't satisfy this anymore, will stop. However, what's going to happen is eventually I becomes 8, and whatever being stored in the array is what? It's just 0 to 7, right? Because the 8th or the 9th I is not being put into the array. 0 to 7. You agree with me on that? Because it's just I to be put in the location I, right? 0 to 0, 1 to 1, until 7, and then it's done. But the thing is, whenever it's done, I will add 1 to itself after that last one. So I becomes A, but the thing is, you only have 7 over here. Make sense? So in that case, then it goes to average. So the average is a 8-bit unsigned integer, and I think it's gonna be fine, because if I'm doing an average of all these 8 numbers, I can imagine it won't be larger than 255. Always keep that in mind, because we have an example after this is actually larger than 255, so you need to assign a different type. So now we just need an 8-bit, which is fine. So now the average is okay. It's calling foo, so foo is actually doing the summation. So call it, right? And then summation is out, and then divided by n is getting the average. Okay? N is 8, so you still have 8 numbers. And this one is doing the summation for you, and then print it out. So we don't need the sprintf and buffer this time, because there's no specifier. We are not doing any certain format. So directly just print it out. And it's a number, just print it out. Loop, not doing anything, just staying there, since we just run everything once. Then we are done. So loop is not doing anything. Curly bracket with nothing in it. But actually what's really happening is, when you run something like this, because the setup function is always just being executed once, okay? So it reaches here, calls the full function, finish everything over here. What's the next step? It print it out, right? And then what's the next? It will still jump to the loop function and just stay there. It's a dead loop. It's not doing anything. That's what happens. Okay, and we want that happen because we just want to print out everything once. We don't want to keep executing this setup function. Okay, so now let's look at this one. It's a full function. It's returning a value, which is, a lot of times if you didn't take C++, you put a type in front of the function. It's actually defining the return type. So the return type means the function will eventually return a value, and that return value has to be defined over here. Okay, it's an unsigned 8-bit result being returned. So because you are returning that value, so that's why you can assign this function's result to a variable, because it's being returned. Okay, if you didn't take C++, that will be helpful. And then this function has 2 arguments. You can just pay attention to the format. It's just by definition. So in embedded C, it's not putting a number here. It's just array, give a space using a bracket. It's not putting a number in there. And so this carries that first variable, which is array, which is the one over here. And the second one carries length, sometimes you can call it width, which is n over here. And then you get into the function. It's going through all the numbers inside the array and adding to sum. So this should be a very simple for loop. Everybody should understand because Python uses the same format, similar format. And eventually you return it. After the for loop is done, you return the sum. So eventually this function will receive that return value and assign to average. Okay? So what is the average? It's basically adding 0 to 7 and divided by 8. It's a very simple example. This is just preparing you for the next one. Any questions for this one? Okay? Next. Modify the code above and make it accepting a 2D array as input and print the average value using the sum returned by a custom function. So changing that array to a 2D array, and you'll need a nested for loop. Search for nested for loop, see how that works. You need I and J, looping through all the rows and columns. And eventually do a sum similar to this, and then find an average. For example, if I'm doing, so make sure that you are doing 8 by 8, okay? 8 by 8. 8 by 8 array. And when you are doing that, you assign eyes to the specific locations, I think. So is that number going to be larger than 255 or not? 2D array. All the numbers are from 0 to 7, 0 to 8. 8 by 8. Probably not. So it's still safe to assign 8-bit numbers to average and sum. If you see issues, you need to make them to be 16 bits. Okay, just let you know. So I'm not going to give you the result over here in the class, but you have to find out either online or something and match our code format like this. If you just totally give me a totally different format, that's cheating. Okay, so you have to follow this format, and which works for Arduino. You have to run it through Arduino, get a result, make a snapshot, put it into your assignment. Make sense? Okay, follow this format. Okay, don't make a totally new thing. You are actually just adding a nested for loop instead of a single for loop. Somewhere here. Okay. Number 14, the last one. What is the problem with the following snippet of code? It's a very similar code. It's not a very new thing. I can see that it's a 1D array, and we're calculating still average from it. It's basically the same code. The only difference is I'm changing the width of the array from 8 to 255. It's a lot of numbers, and I'm adding 0 to 255. So definitely the result will be larger than 255. So in that case, what are the variables? Data type of the variables need to be changed over here. Sum, definitely, because sum will be definitely more than 8 bits. Okay? Anything else? I is fine because it's within 255. What else?
The function return type.
Yep. What else? It's actually average. Why? Why that? Even though the average number will be could be less than 255, but the thing is, if you are using a 16-bit variable inside that average expression or equation, and this needs to be 16-bit as well, because it has a 16-bit number over here, which is a summation, or a return value. Make sense? Whenever something contains a 16-bit number in there, the result has to be 16 bits as well. Just let you guys know. Even though the result could be less than 16 bits, but a lot of times it needs that space for that line. Done. Any questions on this? Any questions on any of the problems over here? No? Okay, now let's get to the board. Something more fun. So this is due Wednesday. In-class exercise due Wednesday on Canvas. Okay. Pay attention to that. Go to my website, click back on controllers, course website. Anyone still doesn't know we have videos and notes posted to the website, definitely check it out if you don't know, if you have any questions after the lecture. So look at the schedule this week. So today we covered something about that, we just finished it, and then you'll look at the board. There will be a homework assignment, homework 2, due Monday next week. Due Monday next week. So you guys have to focus on the assembly of the board this week, because next week we'll start working on certain tasks or labs. I call it tutorials. I don't want to call it lab because we don't have a designated lab time. It's tutorials. So expect that I'm going to explain some of the theories in the class, and you have to work on that either in the lab or at home. Sometimes you can directly work at home, but sometimes you have to use the lab equipment. So that's going to be homework assignments for you guys throughout the semester. Very hands-on. Okay, you have to troubleshoot the board, the code, and deliver the results. So homework 2 will be board assembly, and testing. I think I have a rubric on Canvas. I think it is successfully assemble the board without apparent damages to any of the parts. You cannot just show me a board and has delaminated pads. You know, when you heat up the pads for a longer time, it's going to be delaminated from the board. Pay attention to that, and that won't work for the future labs. So critical. If you see some of the pads are getting delaminated from the board, we have to switch to new one. Even though you can test it, pass, and get credit for homework 2, but you'll fail a lot of future labs. Okay. So anything else on the rubric we can take a look at later, but I think you need to make it programmable. I think for this first time it's really simple. It has to be programmable. Download I think that was a really simple. LED blinking. Have to blink an LED. Okay. So that's all the tasks you need to do for the board. And we have Wednesday, Thursday, Friday. Even during office hours on Friday, I'll still be there. Thursday as well. But you can come to the lab. I'm going to give you access. You can come to the lab anytime you want. You'll have access. So on Wednesday, I'm going to show you the space, the equipment, so you can start soldering on Wednesday. Okay, during the morning. And I also have Monday next week to work on it, because it's due late night on Monday. And the first testing or the tutorial will be a really simple time delay example, and using a speaker on the board, and as asking you to run some time delay, because these are assembly time delay code pieces of lines, and everyone will give you a certain amount of time delay. So it's asking you to find out how many lines do you need to make a 1 millisecond time delay. So you have to use a oscilloscope to do the measurement by changing the different lines over here to find out like how many lines do you really need to make that accurate time delay. Even though this sounds like really silly, because we do have a delay functions in Arduino. You can directly just use a delay something, right? But this a lot of times for a lot of other microcontrollers, they don't have that delay function, so you have to use assembly. All right. So some oscilloscope operation and an example, which is a Morse code. So the Morse code is being displayed on the LED and on the speaker. So the speaker is connected to the audio amplifier on the board. I'm going to show you really quick on the schematic. But the result,
I just removed the breadboard and used.
it is really light. So that's why we need a vibration to the speaker, so it's more a lot more louder.
Still the same task. Still press.
And that's the Morse code for SOS, help. Okay. I'll cover that later, okay? But now you know what I'm expecting for this and next week. Well, these are the tasks. So that's homework 3 for that tutorial 1, which is due Wednesday during the 4th week. And there will be a quiz on Wednesday next week on C programming. So because wait, when is that due? When is the in-class exercise due? This Wednesday, right? So you have a whole week to study all the code on the paper. Okay. Make sure to prepare for the quiz on the Wednesday next week, actually. Now let's go to the board. See what we have on the board. Skyboard schematic. Here's a CPU, or it's actually not just a CPU. It's called SoC. It's a system on chip. It's SoC. It has a CPU, has memories, has a lot of peripherals. So here's the microcontroller itself, has 100 pins, and all these are just the header pins. It's not really, not all of them are connected to certain things, but these are header pins that are made available to you guys, so you can connect to the peripherals. So what are peripherals? Peripherals are sensors, actuators, ports. A lot of other things on the board, available on the board. And if you look at this guy, that's the microcontroller. These are all the header pins. They're just made available for you guys to connect to anything you want. Similar to the Arduino board you have, the commercial one has a lot of all these female header pins. Okay, you can insert the male header pins into it, make jumping wires to make connections. And this is a port for connecting to a speaker. And I'll give you each of you a little screwdriver to tie this up to connect the speaker onto it. And this is a ground loop, even though I should do it in a different way, but keep in mind this is a ground loop, which is really handy because a lot of times you are connecting to a oscilloscope. You want to find a ground pin on the board, so you can directly use a clip and clip it onto the ground. They are both ground pins, okay, to display anything to the oscilloscope. And this is a reset button, as a reset button you have on the board, the commercial one. And these are the pins to burn bootloader, which is a monitor to communicating with the UART when you are uploading code to it. It's actually a set of software being put into the chip and monitoring if there's anything is trying to be sent to the board. It's waiting for that. So it's, whenever it receives that, it's actually directly communicating with the computer and upload all the code to the memories inside the ICOC or the microcontroller. Okay, and over here, this is a little IR emitter. You can see that you have to solder it in this way. Keep in mind, we are soldering this week. Hope you can remember that. Too close. Mm-hmm. So this IR emitter is really interesting because a lot of people will solder it upright. It's a shape like this if you look from the side, and that's a bulb. It's emitting infrared light. And keep in mind, it's super strong and it's invisible, and you couldn't see it, but it's emitting very strong photons or light, power of light. So try to not directly looking at it. For this little jumper here, it's actually making connection to activate it. So I would recommend that unplug it if you're not using it. Actually, just do this, okay? So it's not sending any, it's not activating that IR light because you couldn't see it, but the thing is, it's super strong. It's invisible. It's very strong IR light. It can hurt your eyes. When you are doing the experiment, still try to not directly look at it, okay? If you just put it aside and let it run by itself. So it doesn't have any pins at the bottom, but it has pins on the side. Okay, so when you solder it, you have to put it down. You know, let the side contact your board and solder it over there. So it's confusing because the pin is pretty long. It's from here to here, across all the whole body of the component. It seems like you do have something over here you can solder and keep it upright, but don't do that. So that if you see a pin on the side, you need to lie it down and let the side make a contact with the board and solder it over here. So then it's emitting. So this one is emitting in this direction. And also, that's another thing you need to know, okay? So you can see the light bulb is over here, and you need to keep this direction orienting the outside of the board. So it's actually this direction. So then it's emitting IR, and you'll know that the remote for the TV is super strong. You don't have to directly point your remote to the TV. You can point it to the wall or to something else, somewhere else in the house. This is bouncing back and forth in the house, and eventually the receiver will receive it. It's pretty powerful. So for this one, you don't really have to put an object in front of it to make a reflection. It's actually, even though it's shooting forward, but it will find something and bounce it back to this receiver. So this is the receiver of the IR light. Here's a USB, a quick. Oh, it's already time. I think we'll cover briefly on how to solder the parts. There are some certain rules and tips of soldering surface mount components. I'm gonna cover this on Wednesday. So I'm gonna meet you guys in 610, Furnace 610, which is next door actually. BH 610. I'll get everything set up over there on Wednesday. I'll directly see you there on Wednesday morning. Okay. Any questions by far?
Yeah, so it just clicked in my brain. We have to put all those pieces and make a top board look like the board you're using right now.
Mm-hmm.
Alright. How many components is that?
Say it again?
How many components are
How many components? Not too many. I mean, if you look at the...
Oh, that's like 6.
Here's the layout. And you guys are going to do a layout of this chip at the end of the semester course project. So it could use SD card, could use IR, could use something else you want to use, or any other sensors that you would like to use, which is not available on the board. You can also do that. Okay, you can propose new projects. And you'll be experts in this area, which is exciting, right?